Okay, welcome to 3.1b. Solve this by graphing using the graphing calculator. There's a certain reason why we want to use a graphing calculator in some instances, and I'll explain why in the future. But as of right now, what we have to realize is that 3.1b is very similar to 3.1a. Very similar. It'll have similar solutions as what we had previously. We can have single lines, we can have an intersection, we can have parallel lines, and we can have or an intersection similarly. Okay. Now, all our answers are going to be very similar to how we had consistent and independent, x, y coordinates, those types of things. Okay, and I'll explain to you why sometimes we want to use a graphing calculator. And the best way to show you is by graphing our first system. This is our first system. We still have a slope, negative 3 over 1, 2 over 1. I want us to graph those lines, and I'll show you why it's a little bit hard to tell what things are. First thing I want to do is I'm going to graph my first one. I've already solved for y, so I don't have to worry about too much. Go to 5, and then it's a negative 3, 1. I want to go negative, since it's negative 3, we want to go down 3, 1, 2, 3, right 1. 1, 2, 3, right 1. And so on and so forth until I get that line. That's what it should look like. Then I'm going to at least use my ruler. I prefer straight lines. And there's my line. Okay, now let's do our next one. We have 2x minus 2. I have a negative 2 here. We got to go up 2, right 1. Up 2, right 1, up 2, right 1, so on and so forth. Reverse it. Give yourself a line. There's my second line. So here's the issue. What do our lines intersect? Can I even tell? It looks like they're intersecting in some middle part. That basically tells me that my line is going to be, that my solution to this problem is still going to be an xy, but the solution isn't a whole number. If you remember on our last part, 3, 2, they met on a certain dot. Over here, where's our intersection point? It's in the middle somewhere. So how do I know what that point is and be precise about it? This is where graphing calculator comes in handy. Okay, I want to go over here and I want to show you how we can do this. So I'm going to pull up the graphing calculator and kind of zoom out to here. Follow along. So, graphing on a calculator is actually very easy, as long as you have your system already solved for, meaning that y has already been solved for us. You can kind of see y equals is already there. Okay, that's the key to understanding this. What I first want to do in order to graph this and find that solution on my calculator is this. Go over to the y equals, and you'll notice it pulls up y1, y2, y3, y4, and so on and so forth. Okay, my goal for this is to be able to plug in my equations into the spots y1 and y2. From there, I'll show you how we can do this. First thing I want to do is I type in a negative 3, and then I want to press a specific button when I'm doing x. I have an x here, but I don't want to use an alpha x or green x. I want to use this x, t, theta, n button. You'll see when I press this button right here that it pulls up an x for me. That is the only button I ever want us to press in order to get an x. Nothing else. From there, press plus and 5, and we can do our second equation as well, which is 2x minus 2. Okay? And then I want us to go over here to where it says graph. And now you're going to see we have a similar graph appearing as to our other one. Kind of the same orientation of the lines. They're intersecting somewhere right here, right above the x-axis, a little more to the right than they are above it. Okay, very similar to this one. But how do I figure it? It doesn't tell me exactly what that intersection point is. This is where we have to use another tool that the calculator gives us. It's called calculate. It's this little blue button. It's this little blue thing right above the trace button. And since this is blue, we want to press the blue button first, second, and then we want to press trace. I need us to go down to the intersect. Since we're looking for an intersection point, I need us to figure out where that intersection is. So what you'll first see is that your calculator is going to give you this little thing that's blinking. It says first curve, you can press enter. Second curve, you can press enter. And now it asks you for a guess. You can go over here in the middle if you want and say that's about there, but your calculator doesn't really care. I could have it all the way over here and it would still give me the actual answer because it can automatically calculate it for me. Okay. And look what it's finding. My intersection is x is equal to 1.4 and my y is equal to 0.8. Very similar, and it's hovering right over that point. It's kind of see a little blinking dot there. Okay. It's exactly what I'm looking for. So my solution is actually going to be 1.4, comma, 0.8 or 0.8. The 0 is not necessary. That is my answer to this. But just like our previous problem, our previous section, we still have to put the description of it. Is it consistent and independent? Is it consistent and dependent? In this case, this one is consistent and independent. That's my answer for this one right there. Okay. Now, the thing about graphing on a calculator is that it's only helpful to us if we have an intersection point. It doesn't actually give us an intersection point, it's a parallel line. If I had gone back and done another problem, I would only get one line and I couldn't do this trace function to get an actual, or this trace, or calculate to get an intersection. Okay. It's all dependent on what kind of graph we're looking at is. Now, how do I get back and do my second problem, my B over here? Let's do it. Okay. I want us to press y equals again, and you'll see it takes us right back to where we were. Clear out the first one, clear out your second. And I want us to redo our graph. So this time it's going to be 3 divided by 2 x. 3/2 x is the same thing to me as 3 divided by 2x plus 1. And then this one can be negative 1 divided by 2 x minus 3. I go graph, it'll graph it for me just like that. So I can already tell my intersection is going to be somewhere over in this area of the graph because it's telling me right here on this. Go second, calculate, give my intersection point, press enter, press enter, press enter, and it should give me an intersection point of -2 and -2, which is going to be somewhere right around here. We're going to be right there. Okay, and you'll see that once we actually graph this, that's the case. So our solution is going to be -2 and -2, our xy. Now let's go back and let's kind of graph this actually as we have to. I'm at a +1, and it's 3/2, so it's 3 over 2. So I go up 3, right 2, up 3, right 2, and go. Then I have to do the opposite here. I'm going to go in the same direction, do the same thing, only opposite. Okay. Get myself a good line here. Points on the end, and you'll see it passes right through that -2, -2. Now let's do our next one, -3. And it's a -1/2 x. So if it's a -1/2, we have to go down 1, right 2, down 1, right 2, so on. And look at that. We follow that line right through that point, and it just gives it to us. Okay. The calculator is giving us an actual solution to this equation without us ever having to graph. It's a really useful tool to have, especially once we get into substitution and elimination. Okay, as long as I know how to solve for y, everything should be pretty easy for us. Okay, we'll find -2, -2, just like this one. And again, we still have to put the consistent and independent part here. And that's my solution to this problem. Okay, just as a refresher, if I ever want to calculate where an intersection point is, all I have to do is go calculate. To this blue button right here, that blue right there. I have to press the blue first. Second, calculate, go down to intersect, which is what I'm looking for. It's where they cross, or an intersection you can think of like in traffic for those of you that are about to drive. Press enter, press enter, press enter. and it gives me -2 is my answer, just like our problem is here. Okay, so that's how you do it with the graphing calculator. Hopefully this is helpful to you. If you have any questions, please refer to your teacher or the other video notes.